Hi everyone. In this video we are going to discuss about hybridization. Hybridization. So what is hybridization? Hybridization is a process in which pure atomic orbitals combine to form a set of equivalent orbitals. Let us consider carbon dioxide. So what is the hybridization of carbon in carbon dioxide? So in order to determine the hybridization state of carbon, the first step number 1, we have to calculate the valency electrons of carbon as well as oxygen. So what are valence electrons? Valence electrons are the electrons that are present in the outermost shell of an element. Now consider first carbon. The atomic number of carbon is 6. So the electronic configuration, we should write the electronic configuration of carbon. So electronic configuration is 1s2, 2s2 and 2p2. The outermost shell is 2s2 and 2p2. So the number of valence electron for carbon is 4. Now consider oxygen. Oxygen, the atomic number is 8. So the electronic configuration is 1s2, 2s2 and 2p4. The outermost shell is 2s2, 2p4. So number of valence electron of oxygen is 6. Now in the carbon dioxide we have 1 carbon. So 4 into 1 is equal to 4. 2 oxygen, so into 2, 6 into 2 is equal to 12. So we have 16 valency electrons in carbon dioxide. So first step, calculating the valency electron. So the valency electron of carbon dioxide, we have 16. Okay. Now, step 2. In the step 2, we have to calculate the fractional charge of carbon and oxygen. So in order to calculate the fractional charge, we should assume the molecular structure of carbon dioxide. Assuming the structure of carbon dioxide is CO, single bond O. Now for each bond formation, we need 2 electrons. So 2 electrons for this bond, 2 electrons for this bond. So 16 minus 4, we have 12 electrons in hand. Now the carbon should follow the octet rule. So 2 electrons, here 2 electrons, 4, 6 electrons, 8 electrons. So now how much we have? We have 8 electrons remaining. The 8 electrons can be distributed like this: 2, 2, 2, 6 electrons. So now we have 2 more electrons, the 2 more electrons for this oxygen. Now this is the molecular structure of carbon dioxide. Now we can calculate what is the fractional charge for carbon. The fractional charge for carbon is equal to valency electron. Number of valence electron is 4 minus number of single bond 2 minus number of lone pair of electrons, that is 4. So the charge is minus 2. So what is the fractional charge of oxygen? For example, for this oxygen, right? Now valence electron 6, number of bond 1, number of lone pair 6. So the charge of this oxygen is minus 1. Charge for this oxygen, fractional charge of oxygen is equal to 6 minus 1 minus 2 is equal to 3. So if this is the molecular structure of carbon dioxide, the molecule should be charged. Carbon will have negative charge, this oxygen will have negative charge, this will have the positive charge. But carbon dioxide is a neutral molecule, so this structure is not correct. Now, consider the structure of carbon dioxide is like this: C double bond O, double bond O. Now for each bond formation, 2 electrons. So carbon is surrounded by 8 electrons. It fulfills the octet rule. Now we have 8 more electrons in hand. So you can distribute 2 electrons for this oxygen, 2 electrons for this oxygen. So oxygen, this oxygen fulfills the octet rule. Similarly, this oxygen fulfills the octet rule. Surrounded by 8 electrons, Carbon surrounded by 8 electrons. Now let's calculate the fractional charge for the carbon. Fractional charge for carbon is equal to valence electron of carbon, that is 4 minus how many bonds? 4 bonds, surrounded by 4 bonds. So 4 minus 4, no lone pair of electrons, 0 is equal to 0. Now consider for this oxygen, fractional charge of this oxygen is equal to valence electrons of oxygen is 6 minus 2 bonds, 2 minus number of lone pair electrons, 4. So 0. For this oxygen, fractional charge of oxygen is equal to similarly 6 minus 2 minus 4 is equal to 0. So this structure is the correct structure of carbon dioxide, because the molecule is neutral. Each atom fulfills the structure of the carbon dioxide. So step number 3. Step 3, hybridization state of carbon. The molecular structure of carbon dioxide is C double bond O, double bond O. So this is sigma bond, this is sigma bond, this is pi bond, this is pi bond. So carbon has 2 sigma bond, 2 pi bond. This oxygen has 1 sigma bond and 1 pi bond. Similarly, this oxygen has 1 sigma bond and 1 pi bond. Now the question is, what is the hybridization of carbon in carbon dioxide? So now, first, consider the electronic configuration of carbon in the ground state. The ground state, the configuration of carbon is 1s2, this is 1s2, then 2s2 and 2p2. This is px, py and pz. This is the ground state electronic configuration of carbon atom. In the excited state, the configuration becomes like this. So now in the valency electron, these 4 valence electrons will combine and form a equivalent hybridized orbitals. Now in order to form the 2 sigma bond, now we need 2 equivalent hybridized orbital. So the hybridization is going to be sp hybridization. So 1s2, right, and 2sp1, 2sp1 and py1, pz1. So this is the ground state electronic configuration of carbon. This is excited state electronic configuration of carbon. So this is hybridization state of carbon. Look at the valency shell. Now one s orbital and one p orbital combine and form 2 sp orbital, 2sp1, 2sp1. So these two are hybridization orbital. This hybridization orbital will form 1 sigma bond, and this hybridization orbital will form another sigma bond. This will form a pi bond, this will form a pi bond. In other words, the hybridization orbital having 1 electron will make a sigma bond. The orbital which are not participating in the hybridization and having 1 electron will make a pi bond. So in the carbon at this hybridization state will make 2 sigma bond and 2 pi bond. So the hybridization of the carbon is sp. The molecular structure of carbon is linear. Since the hybridization is sp, the geometrical structure is going to be linear. If it is sp2, it's going to be trigonal. If it is sp3, it's going to be tetrahedron. If it is dsp3, it's going to be trigonal bipyramidal. Now let us consider carbon monoxide, CO. Now what is the hybridization state of carbon in carbon monoxide? So the first step number 1 is calculating the valency electron of carbon and oxygen in carbon monoxide. So the valence electron of carbon is 4, we discussed already. The valence electron of oxygen is 6. So we have 10 valence electrons in carbon monoxide. Now step number 2. Step number 2 is calculating the fractional charge of carbon and oxygen in carbon monoxide. So for that we have to assume the molecular structure of carbon monoxide. So consider this is a structure of carbon monoxide. Now for each bond formations we need 2 electrons. So 2, 2 and 2. So 6 electrons. So 10 minus 6, we have 4 more electrons in hand. To fulfill the octet rule, the 2 electrons can be given to carbon and another 2 electrons can be given to oxygen. So now what is the fractional charge for carbon in carbon monoxide? So valency number of electron 4 minus 3 bonds minus 2, lone pair of electron 2. So the fractional charge for carbon is minus 1. The fractional charge for oxygen in carbon monoxide is 6 minus 3 minus 2 is equal to plus 1. So together the carbon monoxide is neutral molecule. In carbon monoxide the fractional charge for carbon is minus 1. The fractional charge for oxygen is plus 1. Now assuming this is the structure of carbon monoxide, then what would be the hybridization state of carbon in CO? Let us discuss. Now, the step number 3. Step number 3. First, the ground state electronic configuration of carbon is 1s2 and 2s2 and 2p2. Then excited state of electronic configuration, this is 1s2, this is 2s2, this is 2px, this is 2py, this is 2pz. This is the ground state electronic configuration of carbon. Now excited state electronic configuration of carbon is and it's going to be like this. Now what is the structure here? We have carbon has 3 bonds and 1 lone pair, and this is the sigma bond, and this is the pi bond, and this is the pi bond. Okay, so carbon has 1 sigma bond and 2 pi bonds and 1 lone pair. What about oxygen? Oxygen also has 1 sigma bond and 2 pi bonds and 1 lone pair. 1 lone pair. So as I mentioned earlier, to have a sigma bond, we should have the hybridization orbital with 1 electron. To have the pi bond, we should have the orbital with 1 electron. Half-filled orbital we need. For lone pair, we need a hybridization orbital with 2 electrons. Now, according to this configuration, we don't have the lone pair electron. So how to get? Now consider the oxygen. The ground state of oxygen. Oxygen ground state is 1s2 and 2s2 2p4. The ground state and excited state electronic configuration of oxygen is same. Now, in order to have this structure, an electron from oxygen is transferred, right, to the carbon. Now, to have this bond conformation, the carbon should have sp hybridization. In the sp hybridization, the hybridized orbital going to be 2sp, 2 fulfilled, 2 electrons, and 2sp, 1 half filled, this one, and we have px and py. So this orbital will make a sigma bond. These two orbitals, px and py, will make a pi bond. And this hybridization orbital, fulfilled hybridization orbital, will give you a lone pair. So the carbon in carbon monoxide is sp hybridization state. So similarly, you can apply the knowledge to find out the hybridization state of oxygen in carbon monoxide. I hope that you understand how to determine the hybridization state of elements in a molecule. Thank you very much.